Morning. I'm Janie Hagberg. I'm a senior professional engineer in the swim section at the Southwest Florida Water Management District. I've been working on the Lake Hancock project since 2003, so it almost spans my career at the district. Lake Hancock is located in Polk County between Lakeland and Bartow, right off of US 98. Lake Hancock has a history of poor water quality, and that water quality comes from historic land uses, including wastewater discharges, industrial discharges, and also phosphate mining that occurred in the region dating back to the 1940s. Lake Hancock is about 4,500 acres, and discharge from the lake is to the southwest corner, which discharges at a water control structure that the district maintains to Saddle Creek. Saddle Creek meets up with Peace Creek to form the headwaters of the Peace River. Water travels 120 miles downstream along the Peace River to Charlotte Harbor, which is a swim priority water body. The projects that I'm going to discuss are identified in the Charlotte Harbor Swim Plan, the Charlotte Harbor Estuary Program, CCMP, and also the Southern Water Caution Area Recovery Strategy. Looking at Lake Hancock, the district and other agencies recognized opportunities for storage, for flow recovery, to help meet our minimum flows and levels, which the district is statutorily required to address, and also for water quality improvements for the region, and then also habitat improvements. With that, the projects were conceived, and those are the lake level project that I'm going to discuss today, as well as the outfall treatment project. The lake level project is intended to store water in the lake and raise the lake level and release flows in the dry season to provide flow for the Peace River. It will enhance approximately 1,000 acres of wetland in the region and also restore the historic lake level to what it was. The outfall treatment project is intended to address poor water quality in the lake. In 1999, the district concluded a study that looked at water quality in the lake and considered improving water quality in the lake. It was determined that this was not cost-effective or feasible, as dredging the lake would cost in excess of $80 million at that time. So instead, we shifted our focus to treating water discharging from the lake, and that would improve water quality in the upper Peace River and also protect Charlotte Harbor, one of our swim plan goals. In order to implement the Lake Hancock projects, the district undertook a big land acquisition phase. The properties you see here have been acquired for the projects. In excess of 8,000 acres have been acquired. Some of the more notable areas along Banana Creek in the northwest side of the lake, that land purchase was conducted with Polk County, and Polk County manages the Circle B Bar Reserve at that location. And there is a wonderful nature center that they maintain at that facility that they built and also maintain. The projects, or the land for the projects, is intended to offset the floodplain impacts from raising the lake level. We have constructed some conveyance improvement projects in the area, and then also land for the outfall treatment project, and again, those recreational opportunities that I mentioned. And let me review a couple more of the recreational uses. The northeast corner is known as the Hampton Reserve, and that is also going to be parklands, or is parklands, that the county maintains, and there are also equestrian type opportunities in that area. The Fort Fraser Trail, which extends along US 98, will be connected via a trail that will cross the district structure and then go around the lake and provide access all the way around and up to the Hampton Reserve. Now I want to shift focus to the south side of the lake. The district purchased the former Old Florida plantation property, which is delineated here, that's about 3,500 acres, and a portion of that has served as a footprint for the outfall treatment project. You can see the district's P11 structure, shown in yellow, is adjacent to the Old Florida plantation property. In order to raise the lake level to provide that storage, the old structure, which was constructed in the 1960s, had to be replaced. The former structure could only maintain the water to 98.7. We needed to maintain it approximately 1.5 feet higher, so a new structure has been constructed at its location. That construction was completed in 2013, and you can see the new structure here. It is quite an improvement to maintain flood flows as well as lower flows for MFL flow. Now, I would like to focus on the Lake Hancock Outfall Treatment Project. I am the project manager on this project. The view you see here is looking east at that portion of the Old Florida plantation property that was used for the treatment wetland. This is just prior to construction in 2011. And to understand more about the project, it's important to understand the history of the site. This view in the 1970s shows that the property was used for clay settling associated with phosphate mining. You can see the 3 waste cells that were created, and that was constructed back in the 1950s prior to any requirements for the construction of those embankments. That was operated from the 1950s until the 1980s. This view of the site shows the 1984 infrared imagery, and you can see the property is no longer being used for waste phosphatic clay disposal, and it's becoming vegetated. This is the infrared imagery in 1999, and the difference between the two images, I'll toggle back to the previous. You can see that the embankments are pretty well defined, the dikes that contain the waste clay. As part of reclamation that was done in the 1990s, those dikes were pushed over and broadened, and breaches were constructed to drain the water. And this view in 2010 shows the project in much of the state that it was in when we started construction. I'll review the conceptual design for the project. At the inlet that's shown on the map, you see a pump station that pumps water from Lake Hancock into a flow-splitting structure that's shown as the yellow dot. Water from that flow structure is conveyed and discharges into 2 deeper channels and flow across 2 of the larger wetland cells to the south is conveyed to the smaller cell that you see at the lower corner of the map. Discharge from the final cell is back to Saddle Creek, and that again discharges to form the headwaters of the Peace River. Just a little bit about treatment wetlands. This, of course, South Florida has implemented over 60,000 acres of treatment wetland. And there are lots of processes that are going on in a treatment wetland. I think we all understand plan uptake. However, that component of a treatment wetland is a temporary or not a complete transformation of nutrients, in that when the plants die, you have a release of nutrients. But there are other processes that are physical and chemical that are going on, and biological, really most importantly, that affect the nutrient removal that we are seeking for the project. Most importantly, our goal for the project is focused on nitrogen removal. We are looking to remove 27% of the nitrogen load from discharges to the Peace River. And the good thing about a treatment wetland, it is a real workhorse for nitrogen removal, and that the microbes that populate on the surface of the vegetation is really the workhorse of that system that is causing denitrification to occur, which actually gives off the nitrogen and N2 gas to the atmosphere. So it is actually a complete removal for the nitrogen for the denitrification processes that take place. So with that, our goal in the project was to grade the project site, that is, conduct earthwork to grade at level. We wanted to maximize that population of emergent wetland. And there was variability across the topography or the elevations across the surface, so that had to be graded. And what you're looking at here is a cut fill map for design grades that would maximize the surface area that would be graded level, and then that would be home to the emergent wetland. So you have cuts to fills, and the importance and why I'm focusing on this map is that we wanted to balance that cut and fill. And that is because the phosphatic waste clay that was left in the area is really of no value. It's difficult to work, and we wouldn't want to haul it off site, but we also want to maximize that treatment area. So construction of the project began in September of 2011. And just to talk about some of the components of the construction, cell grading is what I'm talking about related to grading the site and conducting that earthwork to create a level site for the emergent wetland. We have water control structures, concrete structures that convey the flow from cell to cell, and also discharging to South Saddle Creek. We had to reinforce the embankments to make sure in higher flow situations that we would hold the water and not have breaches in the dikes. Again, dating back to when in the 1950s when these dikes were originally constructed, they weren't engineered as they would be today. So we wanted to make sure that we didn't have any breaches and lose water. There is a pump station that was constructed. The flow is really only a portion of the flow that would discharge over the district structure, so that we are going to divert a portion of that water that would have gone over the structure that I showed you and would now flow through this wetland system and discharge down Saddle Creek to the Peace River. And then finally, the last step were the wetland plantings. Construction, inclusive of all of those components, was complete in April 2014, and plan establishment is currently ongoing. Now I want to show you some aerial images and photographs during construction, just to give you a feel for what it took to get this project built. This view is looking east at the project site, and you can see this is about 1,000 acres that is cleared in this image. The contractor on the project used pans that were pulled by John Deere tractors, and each one of those pans can hold about 17 cubic yards. And they're able to scrape the material from the bottom. That loads the pan. They drive to where they want to place that material and release it. And in the cell grading area, they could actually, just by driving over the material, compact it and place it. This shows the pans being operated for the embankment work, and those were the dikes that I mentioned that were being reinforced to hold the water back within the wetland cells. This was a fleet of the tractors and pans working in one of the cells on the grading. This is about 17 months into construction, and we're actually nearing completion of the cell grading. That orange color that you see is the phosphatic waste clay. It was a very competent layer that the earthwork was done in and proved to be very difficult to work with. And this image really, I think, shows you how difficult. You can see that it kept that vertical wall. It was almost at times you could, like an ice cream scoop, that the material would creep up the bucket. And it was just that type of a consistency to work with, but much more firm, of course, and sticky. This is inside of one of the excavations where they're constructing one of the water control structures and forming up the foundation for that structure. The water control structures were built in many phases to form and pour the walls that were needed to control the water. This is two 36-inch HDPE pipes that are extending from one of the control structures, extending through the dikes, and then into the next cell to convey water. And this view of the pump station along the south shore shows the construction. And this view is actually an aerial view looking down on the pump station from the opposite view. You can see the bays for the intake of the water. Those are about 18 feet deep. There are 3 submersible pumps located in those bays that pump water to the piping, and then that is conveyed up into the wetland cells. There's also a control building where we have our instrumentation and controls, and it can be remotely operated from our Brooksville headquarters. This is a view of the discharge channel going back to Saddle Creek. Just beyond the box culvert is actually Saddle Creek, which is now lined with riprap. One of the components of the discharge channel and the structure is an aeration structure, and this is a view of that aeration structure. It is a passive stair-step structure that just via the turbulence of the water traveling down that structure induces oxygen. And that's necessary because a treatment wetland naturally lowers the oxygen, the dissolved oxygen in the water. So here we're reintroducing that oxygen before it discharges to Saddle Creek. And here is an aerial view of that structure and channel. And that is just south of that final cell before discharge into Saddle Creek. Now, the final phase of construction was the wetland planting. And we planted the site in strips that you see here. They're about 30 feet wide and 250 feet apart. We knew and expected that we would have recruitment of vegetation, but we wanted to plant with a diverse population of emergent wetlands just to increase that diversity. This shows the plants being delivered to the site. They were harvested from permitted donor sites and brought to the site. In the wetland cells, we were managing water at about 4 inches, which we found to be optimum for recruitment and promoting that vegetation growth. And this is one of our environmental scientists conducting inspections using an amphibious ATV vehicle. He was able to get into the center of the wetland cells and really see what was going on. And here you see the vegetation from one of the strips beginning to take off. You see spike rush, pickerelweed, thalia, and duck potato as well, I believe. And lots of wildlife usage. We have the white pelicans that come in the winter, limpkins, great blue herons. And this is an aerial view from September 2015 of one of the cells. This is the western cell. And it shows how some of the areas have recruited and taken off better than others. This is the same day in the lower cell, and I just wanted to show you the difference in the recruitment. You can see how full the coverage is, and there are cattails, and we do actually, we're happy to have the cattails. Those are part of the workhorse of a treatment wetland, providing that surface area that I mentioned for the microbial populations to populate and drive that denitrification and water quality improvements. This view on the same day shows the pump station and 2 of the cells in the background. I do have a theory why one cell did not recruit as well as the others, and it actually was contrary to our original thinking on the project. What happened, the other cells that had the very good recruitment and establishment of vegetation, they were graded first. And so they sat dry and had quite a bit of exotic species and uplands nuisance come in. We were very concerned about that. The other cell was the last area to be graded, so the grading took place in that phosphatic waste clay. It was very quickly flooded and planted. What I think is that vegetation that had recruited provided a substrate for the vegetation that once it was flooded, they didn't survive, and you actually had the wetland vegetation have a better base or substrate to grow in compared to that more virgin material that was just scraped and then flooded. We are seeing more recruitment now, but it is taking a little bit longer than we had expected. The project costs. For all of the projects, including land acquisition, the district spent about $170 million. About $131 million of that was on land acquisition. The P11 structure was $6.5 million. The conveyance improvements in the region, $7 million. And then the outfall treatment project, including design, was about $24.5 million. We do have a web page on our district, the SWFWMD website. Watermatters.org is another way to access it, and you can look up the Lake Hancock projects. We have the aerial imagery that was taken monthly during construction of both the lake level project and the outfall treatment project. And that picture is from the pump station, the riprap out in front of it. We have a lot of large alligators in Lake Hancock. Do you have any questions? What is the biggest surprise and the biggest success? The biggest surprise was that cut to fill balance that I mentioned. We actually found that the clays were quite compressible, and so we didn't actually get to that exact acreage that we wanted, and that was not expected. I think the biggest success is really just completing the project and also seeing the wildlife habitat that has come in. We have such a population of birds that are utilizing the site. It's really just phenomenal to see.
Why did you guys choose to specifically remove 27% nitrogen?
Oh, the load reduction?
Yes.
We looked at, it was really a feasibility analysis, and the benefit downstream, we weren't achieving an additional benefit with a greater load reduction. It was really that cost break point that led us to the 27% nitrogen load reduction.
Thank you.
Thank you.
Thank you.